Hi there everyone, in this video we're going to be going through the idea of change in scale of origin as it applies to continuous random variables. Now this idea is very simple and we've been through it before with discrete random variables where we multiplied by a certain number and added on a certain number, and we were interested in finding out what happened to the mean and standard deviation and variance when we did that. Well, the results from there carry over to the results for continuous random variables. So if we start with a certain set of data, let's go back to data, we multiply everything by 2, then the mean is also multiplied by 2 and the standard deviation is doubled because the values are more spread out. If we just say add on 10 to each value, then the mean is 10 more than it used to be, but the standard deviation and variance don't change. So hence these formulas here. When we start with a random variable x, and then we end up with another random variable, which is ax plus b, that's this one here, then the new mean is we've got to times by a and add b. The standard deviation is the modulus of a times the old standard deviation. And the reason why we've used that modulus sign there is because we might multiply every value by -2, for example. That still doubles the standard deviation. So the modulus of a, and the variance is a squared times the old variance. So let me show you how this looks in a continuous random variable kind of question. So this question here, we've got a uniform continuous random variable defined between 24 and 144. I've quickly sketched this out. This is not to scale, but just to give you an idea of the continuous random variable we're dealing with here. So we want to know the expected value, variance and standard deviation of this random variable here. Okay, so the last video we dealt with working out all these sorts of things. So let me go through the easy way to do it. The expected value x is going to just be halfway between 24 and 144 because it is a uniform continuous random variable. So it's just the average of 24 and 144. And when you do that, you should get 84. Okay, so that's 84 right in the middle. So that's the expected value or the average or the mean of this continuous random variable. We also worked out how to do the variance. I'm not going to go through that again, but here's a quick little formula. It's a bit of a cheat formula here. B minus a squared over 12. Now this little formula works only for uniform continuous random variables. So B and A in this case are the endpoints of the interval. So here we've got 144 and 24. 144 minus 24 squared over 12. And if you do that on your calculator, you should get 1,200. So the standard deviation of x is just the square root of 1,200, which is around about 34.64. So that's the results for x. What about y? For b, y is just 3x minus 4. So the expected value of y is just 3 times the expected value of x, which we just worked out was 84 minus 4. So do that on our calculator and we should get 248. The variance of y and the standard deviation of y. The variance now, because we've times by 3 and then subtracted 4, the minus 4 doesn't make any difference, but the multiply by 3 triples the standard deviation and the variance is bigger by a factor of 3 squared. So it's 3 squared times the variance of x. Okay, so 9 times the variance of x was 1200. So the variance of y, 9 times 1200, which is 10,800. So the standard deviation of y is just the square root of that. The square root of 10,800, which is around about 103.92. So it's really just a matter of using that idea of the connection between y and x and how you deal with the mean and the variance in each case there. That'll get it for you.